Welcome to Eureka Math. This is Module 2, Lesson 12, and we are going to continue multiplying decimals and whole numbers. So our objective is to reason, mean to think about, right? Think about the product, and the product is, of course, the answer to any multiplication problem. Oh, my handwriting isn't staying. Of a whole number, so something like 12, and a decimal, something like 2.4, with hundredths, 2.45, using place value understanding and estimation. So what we're really doing here is we're adding digits onto our multiplication. So this is more of the same from lesson 11 and lesson 12. The numbers are getting bigger, okay? Lots of practice with this. So let's go to your problem set. And that is the lesson 11. Here it is, lesson 12 problem set. Name on your paper. And we'll start right off with number 1. It says estimate. Then solve using the standard algorithm. You may, which means it's optional, draw an area model if it helps you. Okay, so first estimate. We have 1 and 21 hundredths, so we're going to round that down to 1 whole. And 14 wholes, well, we can round that up to 15 if you want. 1 times 15 is 15. Okay, we could round it down to 10 as well. Doesn't really matter because what we're looking for is something that's going to help influence our final answer. So it says we may draw an area model. I think on this first one that we'll go ahead and do that. And what I'm going to do here is I'm going to turn this 1 and 21 hundredths into 121 by multiplying by 100. Okay, or I could just call that 121 hundredths if it makes you feel better. Okay, THS. And I'm going to put my 100 here, my 20 there, and my 1 here. So there's my area model. And of course, here, the 4 and the 10. So 14 times 121 hundredths. 4 times 100 is 400. 4 times 20 is 80. 4 times 1 is 4. That's going to give me 484. Again, this is hundredths. Here, 100 times 10 is 1,000. 10 times 20 is 200. 10 times 1 is 10. Which gives me 1,210 hundredths. And then I'm going to add that. So I have 4, 9, 6, 1. And those are hundredths. So what am I going to do over here? I multiplied by 100. So I'm going to divide by 100 to get my new answer, which is going to give me 16 and 94 hundredths. So if my estimate was 15 and my answer is 16 and 94 hundredths, that's a pretty close estimate. Okay, so I'm actually going to erase this, my thinking here. That was all my thinking. I'm going to erase that so I have enough space for the standard algorithm. So I've done my estimate, I did my area model, and now I'm going to do my standard algorithm. So 4 times 1 is 4. 4 times 2 is 8. 4 times 1 is 4. Drop the 0. Right, and you can see the parallels there. 1 times 1 is 1. 1 times 2 is 2. 1 times 1 is 1. Again, you can see that those numbers match. 4, 9, 6, 1. And because I've got 2 decimal points up here, I'm going to roll 2 decimal points here and put them back in. Okay, so I did my estimate, my standard algorithm, and my area model. Just bigger numbers, 3 digits instead of 2. Okay, next one. 2 and 45 hundredths is going to go down to 2 wholes. And let's say 300, so that's going to give me an estimate of 600. Okay, and do I want to do my area model? I'm going to. just for those of you who like that area model. I didn't grow up with the area model, so I don't use it very often. I was classically trained in the standard algorithm, but that's okay. Let's see, 200 here, 40, and 5, because I turned this into 245 by multiplying by 100 in my head. Okay, and on this side, I'm going to need another space, aren't I? Because I have 3 digits on that side as well. I've got 5, 0, and 300, right? 0 tens. So honestly, I really don't need this one, but I'm going to keep it there anyway. 5 times 200 is 1,000. 5 times 40 is 200, and 5 times 5 is 25. So that's going to give me 1, 2, 2, 5. Then 0 here, and then 300 times 200 is 60,000. 300 times 40 is 12,000. And 300 times 5 is 1,500. Let's add that all up. That's going to give me, let's see, 7, 3, 5, 0, 0. Is that right? 60,000 plus 12,000 is 72,000 plus, nope, I did put the comma in the wrong spot. 73,500. Okay, then I'm going to add, which is kind of messy because that's so far away, but I'm going to try and keep things in a line. So 5, 2, 7, 4, 7. Lots of numbers. But remember, I multiplied by 100, so in my head I'm going to divide by 100. And that's going to move my decimal point right here, 747 and 2500ths. My estimate was 600, so that's okay, reasonable. All right, let's do the standard algorithm here. 5 times 5 is 25, carry the 2. 5 times 4 is 20, plus 2 is 22, carry the 2. 5 times 2 is 10, plus 2 is 12. Okay, that looks the same. Then the 0 I'm just going to leave, okay? But I am going to put the 300 in there, so I'm going to go ahead and put 2 zeros right away. You can see those 2 zeros right here. 3 times 5 is 15, carry the 1. 3 times 4 is 12, plus 1 is 13. Wait a minute, did I make a mistake down here? 3 times 4 is 12. I might have. This is why it's a good idea to do it 2 different ways so you can catch mistakes. 5 times 5 is 25, carry the 2. 5 times, I know that's right, okay. Then the 0. And this is 5, carry the 1 is 12, 13, carry the 1, 7. Look at that. No. Oh, I did okay. I'm sorry, I was getting confused by the answer down there. All right, now add that together. 5, 2, 7, 4, 7, and 2 decimal spots here, so 2 decimal spots here. There's my answer, 747 and 25. Very good. You guys are getting good at this. We've been doing this for a few days now. First estimate, then the standard algorithm. If you want to draw an area model on a separate page, you can, but you do not need to. It says, if it helps you, which means it's optional. Okay. I'm not going to do the area model for the rest of these, but if you need to, please go ahead. And my estimate here, I'm going to turn that into 1, 1, and I can keep that at 12 if I want. My estimate is 12. Then I'm going to multiply. 2 times 3 is 6, 2 times 2 is 4, 2 times 1 is 2, drop the 0, 1 times 3 is 3, 1 times 2 is 2, 1 times 1 is 1, then add 6, 7, 4, 1, and I multiplied by 100, so I'm going to divide by 100. My answer is 14 and 76 hundredths. Okay, next one. I am going to, let's see, I'm going to estimate that down to, or round that down to 1. And this I could just keep at 26, that's fine. Did you see how this 14 and 76 hundredths is similar to 12 there? So here's my estimate, 26. 6 times 3 is 18, carry the 1. I should draw, I'm starting to lean sideways, so let me straighten out and draw just a little bit smaller so it all fits on the page, huh? Be neater about this instead of rushing. I know you guys like to rush, so I was trying to rush too, but I gotta slow down. 6 times 3 is 18, carry the 1. 6 times 1 is 6, plus 1 is 7. Drop the 0. 2 times 3 is 6. 2 times 1 is 2. Then I've got 8, 13, carry the 1, 3. So what do? This, in my head, only had to multiply it by 10 because there's only one decimal there. So let's go ahead and put that decimal back in. 33 and 8/10, and 26 was my estimate. Pretty close. All right, let me change colors. Okay, well, what should we do here? If I round that down to 0, 0 times 14 is 0. Well, I guess I could. Or I could just keep it at 2/10 times 14, and that would give me, what would that give me? 28, but it would actually be 2.8, right? Is that right? Let's see what we get. Okay, so 4 times 3 is 12, carry the 1. 4 times 2 is 8, plus 1 is 9. Drop the 0. 1 times 3 is 3. 1 times 2 is 2. And I've got 2, 9, 10, 11, 12. Carry the 1, 3. And put the decimal point back in. Oh yeah, look at that, 3 and 22. And my estimate was 2.8. So if you want to estimate with decimals, you can. You just have to be kind of careful, right? Because if I were to put that down to 0, 0 times 14 would be 0. And that's not a very good estimate for what our final answer is. So I just put it to 2/10, and then 14 times 2 is 28, but then I had to put the decimal back in, right? So 2 and 8/10. I could do the same here. If I wanted to, I could estimate that as 25 and keep that as 5/10. And 5 times 25 is 125, but put the decimal back in and I would get 12.5, right? So let's see, which makes sense because half of 25 is 12.5. So let's see what we get when we solve this. 6 times 5 is 30, carry the 3. 6 times 4 is 24, plus 3 is 27. Drop the 0. 2 times 5 is 10, carry the 1. 2 times 4 is 8, plus 1 is 9. And 0, 7, 11. And then I've got 1, 2 decimals here, 1, 2 decimals here. So my answer is 11.7, 11 and 7/10. Or 70 hundredths, but I don't need to put that 0 back in. So if my estimate was 12.5 and my answer is 11.7, not too far off. Let's change colors again just because it's fun. And here I'm going to estimate 7 times 30. So that would be 210. And I am going to, wait a minute. Let's see, 706 times 2, 8. 8 times 6 is 48, carry the 4. 8 times 0 is 0, plus 4 is 4. 8 times 7 is 56, then drop the 0. 2 times 6 is 12, carry the 1. 2 times 0 is 0, plus 1 is 1. And 2 times 7 is 14. Oh my gosh, I gotta stop writing sideways here, I'm sorry. 8, 6, 7, 9, 1, and my decimal goes right there. Did you see that? 2 spaces over, so 2 spaces over. 197 6800. Next one. Okay, let's call this one 6. And this one we'll just call 200, which would give us 1,200 as an estimate. 632 times 223 is, I'm going to draw smaller here, try to, because I don't have as much space and there's 3 digits. So 3 times 2 is 6, 3 times 3 is 9, 3 times 6 is 18. Drop the 0. 2 times 2 is 4, 2 times 3 is 6, 2 times 6 is 12, and then 2 zeros. 2 times 2 is 4, 2 times 3 is 6, 2 times 6 is 12. And now I've got 6, 13, carry the 1 is 9, plus 6 is 15, plus 4 is 19, carry the 1. 1 plus 1 is 2, plus 2 is 4, plus 6 is 10, carry the 1. And 1 plus 1 is 2, plus 2 is 4, and 1. Okay, now I have to put my decimal point back in, and my answer is 1,409 and 36 hundredths. Pretty close to my estimate. Let's go green. Okay, 7 and 6 hundredths. I'm going to round down to 7. I'm going to round this to 200, and that's going to give me 1,400 and 706 times 208, and 8 times 6 is 48, carry the 4, 8 times 0 is 0, plus 4 is 4, 8 times 7 is 56, and I'm going to skip the zeros. I'm going to just add 2 zeros right away for the 200ths place. 2 times 6 is 12, carry the 1, 2 times 0, 0 plus 1 is 1, and 2 times 7 is 14. Okay, and I've got 8, 4, 8, 6, 4, 1. And if I put my decimals back in, my answer becomes 1,468 and 48 hundredths. Okay, let's see, what do we want to do here? We could round that up to 200, or we could keep it at 150. Let's just go ahead and round it up. 200, and this I'll round up to 600, and that's going to give me 120,000. Lots of digits here. Okay, 1, 5, 1, 4, 6 times 5, 5, 5. 5 times 6 is 30, carry the 3. 5 times 4 is 20, plus 3 is 23, carry the 2. 5 times 1 is 5, plus 2 is 7. 5 times 5 is 25, carry the 2. 5 times 1 is 5, plus 2 is 7. Okay, next one, drop the 0. 5 times 6 is 30, carry the 3. 5 times 4 is 20, plus 3 is 23, carry the 2. 5 times 1 is 5, plus 2 is 6, 7. Wait a minute. Let me make sure I'm doing this right. Yep, 7. 5 times 5 is 25. Carry the 2 is 7. Look at that. Because these numbers are all the same, these numbers are also the same. So for my last one, I can add 2 zeros, right? And then I can go ahead and add a third 0, and a 3, and a 7, and a 5, and a 7, and I already know that that's going to be the answer because 5 times 5 times 5, they're all the same numbers. 0, 3, 10, carry the 1, 6 and 7 is 13, plus 3 is 16, carry the 1, 7 plus 1 is 8, plus 5 is 13, plus 7 is 20, carry the 2, 7 plus 2 is 9, plus 5 is 14, carry the 1, is 8. Wow, that's a big number. Okay, so I put my decimal point back in, and what did I get? I got 8, 4, 0, 6, 0, and 3 tenths, or 30 hundredths if you prefer. 84, yeah, I guess that's a pretty close estimate. 120,000 is big, but if we had kept this at 150, that would have been 6 times 15 would have been 90,000, right? We could have done that, and that would have been a closer estimate. It just depends on where you want to round to find your estimate. Okay. All right, number 3. Denise walks on the beach every afternoon. In the month of July, she walked 3 45 miles each day. How far did Denise walk during the month of July? Okay, so 3 4/45 miles times the month of July. Okay, if you don't know how many days are in the month of July, let me show you a trick. Okay, this is what I learned when I was a little kid. All right, so your knuckles on the top of your hand form peaks and valleys, right? And I always start with January is the big knuckle because it has 31. February is in the valley, so it's 28. March is the big knuckle, so it has 31. April has 30 because it's in the valley. May has 31 because it's a peak. June is in the valley, so it has 30. July has 31 because it's a peak. Then you count backwards. August is 31 because it's on the peak. September is in the valley, so it has 30. October has 31 because it's the peak. November has 30 because it's the valley. And December has 31 because it's the peak. So peak, valley, peak, valley, peak, valley, peak, peak, valley, peak, valley, peak. Okay? It's a silly way to remember, but it helps me. So January, February, March, April, May, June, July is a peak. It's on the top of my knuckle. So that's 31 days in July. So July has 31 days. And if you don't have that memorized, that little trick will help you. And if you can't remember my little trick, you can look at a calendar, I guess. That's fine too. So we want to multiply 3.45 times 31 to figure out how many miles she walked in the whole month if she walked every single day. That is dedication. Okay, so 1 times 5 is 5. 1 times 4 is 4. 1 times 3 is 3. Add the 0. 3 times 5 is 15, carry the 1. 3 times 4 is 12, plus 1 is 13, carry the 1. 3 times 3 is 9, plus 1 is 10. And then I add 5, 9, 6, 0, 1, and I'm going to put my decimals back in. I had 2, moved it over 2, so I'm going to move back 2. And she walked 106.95 miles in July. Okay. Number 4, a gallon of gas. I know we use liters of gas here. Gas right now in Venezuela is 50 cents a liter. In gallons, I don't know. But that's the international price that's set. But when you have to buy black market gas, it goes up, doesn't it? Okay. Gas shortages. This is our daily lives now. La cola para gasolina. Okay, a gallon of gas costs $4.34. Greg puts 12 gallons of gas in his car. Okay, so he had, each gallon cost $4.34, and he put 12 of them in his car. Okay, so we want to figure out how much money that cost. And then he had a $50 bill. So how much money will Greg get back, right? How much cambio will there be? So we're going to find whatever this answer is, and then we're going to subtract that from 50. But I'm automatically going to put in 2 zeros because we're talking about money. So, okay, and then subtract whatever this answer is from here. Okay, so those are our 2 steps to this problem. This is a 2-step problem. So let's find out how much money he spent first. 2 times 4 is 8. 2 times 3 is 6. 2 times 4 is 8. Drop the 1. 1 times 4 is 4. 1 times 3 is 3. 1 times 4 is 4. Then add 8, 10, 9, 10, 11, 12. Carry the 1 is 5. And, all right. So guess what? He doesn't have enough money, does he? If it's $52 and he only has $50, in fact, we are going to have to subtract the other way to find out how much he needs to find, right? And I don't think the gas guy is going to give him a deal. So he's going to have to dig in the seats, maybe open up the trunk, see if he can find any extra change. But he needs to find $2.08 to pay what he owes. He will still owe $2.08. Gas is expensive. Okay, number 5. Is this the last one? Yes, number 5. Seth drinks a glass of orange juice every day that contains 0.6 grams of vitamin C. He eats a serving of strawberries for snack after school every day that contains 0.35 grams of that vitamin C. How many grams of vitamin C does Seth consume in 3 weeks? Okay, so wait a minute. I'm trying to think. Well, he doesn't go to school every day, does he? So is this 3 weeks 3 school weeks, which would be 3 times 5? Or would it be 3 full weeks, 3 times 7? I'm not quite sure. It's not clear in the question, is it? Well, let's solve it both ways, and then we'll go look at the answers to see what they decided. Because logically, in my brain, if he's eating his after-school snack, it means on school days. But, okay, so when we add decimals, remember we have to line up the decimals, so I added a 0 here. So I've got 5.9, right, grams. And if I multiply that by, well, 15, or I could multiply it by 21, depending on which answer they're looking for. So let's do both, just in case. And then we'll look it up. 5 times 5 is 25, carry the 2. 5 times 9 is 45, plus 2 is 47. Drop the 0, 1 times 5 is 5, 1 times 9 is 9. 5, 12, 14. Okay, 14.25 grams on school days. And 5, 9, 0, 10, 18, 19. And if we say every day, that would be 19.95 grams. Okay, so this is if we're counting 3 weeks as being 21 days. And this is if we're counting 3 weeks as only being 15 days. Let's just see what they put in their answer book, because I think this could go either way. And if you were to give me this answer on a test, I would take it. And if you were to give me this answer on a test, I would take it too, because the wording isn't very clear. Let's see what they thought 3 weeks was. Right? Aren't you curious? I'm curious. Okay, 3 weeks equals 20. Oh, look at that. They did both. 3 weeks after school. Right? Or, oh, I see what they did. That's even trickier. Oh, Tricky people. Okay, do you see what they did? They said that he has the orange juice every day, so the orange juice would be 21 days times the 6 grams, right? Which would be 12.6 grams. And then only had the strawberries on school days, which is 15 days. So that's 15 times 35, which would give us 95 plus 450, 525 grams. And then they're saying you have to add those together to see how much he had in 3 weeks. Tricky. That is tricky. That is not how I would have read that question. Not the best question. Okay, well, so I guess this answer would be acceptable, this answer would be acceptable, and I would take this answer too, because that's the answer they gave in the book. Interesting. Let me just read this one more time. Seth drinks a glass of orange juice every day that contains he eats a serving after school every day. Wow, that's tricky. Interesting. All right, that was a tricky one. But I like those questions too, because you can see all the different ways to get different answers. As long as you show your work and show your thinking, I would accept any of those answers. Wonderful. Have a great rest of your day, everyone.